Hey everyone, welcome back. Sorry for the massive extended delay because I was dealing with some monstrosity of cabling here. It's a little scary to look at, but there's method to the madness. Few updates. Obviously, big delay. Life kind of got in the way, but kind of got a bit of time to get back onto it. A few nights really late over the last few months. Massive cock up in my BNS wiring, particularly on the battery tap harness. I found, well, I shouldn't probably say massive cock up, but reasonable size cock up. The weird thing about this type of BMS is that it has groups of cell taps that go into groups of cells, and clearly wasn't reading the instruction manual clearly and paying enough attention to it at 2 a.m. in the morning. But long and the short of it is that every group, so these orange, red and yellow taps, also has a negative divider tap, and they put that in there with good reason. It allows you to split your pack up into component parts and put a fuse between. So effectively, one of the cell taps is duplicated on a single cell, or at least that's what the BMS sees, if you're wiring these all in series and with no fuses. What happens is if you're putting fuses in, you put that negative one and then the next one along between the fuse, and then that way the BMS has each group completely isolated if you pull the fuse out, and then effectively doesn't destroy the BMS by running a huge amount of current through these tiny cables and fry all the electronics inside. That's the intent behind it. So it's taken me absolutely freaking ages to sort through that because I was getting a whole heap of error codes when I fired the BMS up. Anyway, I even thought I had an issue with the cell wiring harness, so I bought one of their cell wiring harness checker tools. It cost me a freaking fortune, but it validated that I'd done my cell harness correctly and ruled that out, because there is about 8 gajillion variables that you're working with when you're working in here, because I'm integrating a whole lot of things. In this battery pack, it's never been built before. No one has ever built this type of battery pack before in this configuration. I'm the first. There are plenty of people that build battery packs, but exactly the same as this. It's unique. Big lessons learned. Absolutely never put your cell tap inside where you can't access them. Massive lesson learned there. I did this so I could get a heat transfer surface here on the ends of the cells, so it's with good reason, but I would probably consider getting heat transfer some other way in future, because I thought for a moment, and a butt puckering moment, that perhaps my cell taps, which are buried on the back of these PCBs, if you want to know what it is, go back to my previous videos, were wrong, and I'd stuffed them up, and that was that sinking feeling, similar to when you've lost your wallet, or you may have run over your neighbour's dog or whatever. So that's a big one. Second one, I've introduced a 12 volt DC battery, which is just your standby battery. Even Teslas have those. Cybertrucks don't now, but they got a 36 volt one. The 12 volts are AC to DC converter, so this takes AC from when you plug it into your street charger, converts it to DC, and it lets the BMS know that it's plugged in, and also uses power while it's charging. The battery charger, which is buried down underneath the motor controller, so that's fully integrated now. So the battery charger is talking to the BMS, so I've got that talking via CAN bus, which in of itself was a nightmare. I couldn't get it to talk for a long time, and then I discovered that this needed a firmware update to allow McKinney's Type 2 connection for 32 amp charging rather than Type 1 type charging for lower 15 amp charging. So that took me a long time, and of course TC or Alcon chargers have absolutely zero technical support. Really good Chinese manufacturer, extremely good quality, very diligent on their quality, very diligent on their design, just no technical support. You're on your own. So if you're a noob like me, probably if you can and you got a shop near you that sells them, work with the shop. Now that I know what I know now, this will be really easy. I can just purchase these straight off the manufacturer in China, and I'll integrate straight in with this system. I've got the lay of the land now on how to do that. I've got the recipe book, and I guess this is what all the shops charge you for. Massive amount of setup done in the BMS software itself. The BMS software, you've got to do a whole bunch of configuration around your cells, all of the particulars of that. So there's a huge amount of setup here, which has been a bit of an interesting exercise to go through. I certainly understand a lot more now about lithium-ion cell management than I did at the start. So that's a huge one. All the HV stuff is now fully, temporarily sort of wired in. It's safe enough to do so now. Everything's insulated, so that's all wired in, ready to go. All the main contactors are ready to go. In theory, I can just hook up the main battery contacts to the main power contacts on the controller. The last thing in the piece of the puzzle is the controller harness. So I've started getting that ready with some of the plugs that are required. So there's your CAN bus there, that's all ready to roll. First things first, probably with it, I'll get it configured so I can hook it up to some juice, and then start to plug into it, get CAN bus talking to it through the CAN bus adapter, and then get it rock and rolling. One thing I did find in my aftermarket isolation box, air gap box, I guess you could call that, the air gaps all of the workings of this guy, because that all works at battery voltage. So all the switching for all of your ignition switch and everything like that is all at battery voltage, which really is shit. You don't want full battery voltage running through your harness, particularly mixed in with 12 volts or even lower 5 volts signal wise and all that kind of stuff. That's what I really hate about these Sevcon controllers, or at least the Gen 4s. The newer Dragon ones are fully separated or isolated, but they don't have as high power as these guys. They're about 80 odd percent, so there's not power there, and I want everything I can get out of this sucker, because it's about matched to the motor. So one thing I did find about this is one of the relays was welded shut from factory, which caused me all kinds of havoc. I was looking for that problem for a little while. So the good thing is that I now have a EV charger type 2. So this is what you would find out in the street, and I have my charging port here, which is really well mounted in the vise, but I promise it's insulated. So if we plug that in, you can hear main relay come in, chargers talking to the charger, and we hear the cooling fan come on. So now we can connect to the BMS because it's livened up. So we'll think for a while it's starting to connect. And we can go to live data, and we can see it's really small, but it is charging at 3.3 kilowatt. So we are pumping in 3.5 kilowatt into my battery pack, and we can have a look, some live cell data as well. So we can see that we've got our cells moving around. We're at 3.8 volts and we're climbing quite quickly. So and we're pumping in nearly 30 amps of DC charge. So we'll go from 52% to fully charged quite quickly now. So I'm really impressed with this charger, super impressed with this setup, and I've checked all my safety interlocks now, so when I rip my charger out, it all drops out, tells the charger to stop, BMS goes, yep, you're done, main contact is shut, and all done and dusted. So I've also fiddled around with the top voltages as well, so I've artificially reduced the voltage of the pack, and I've made sure all the safety interlocks work where it kills the charger. So there's two things that happen: the CAN bus kills the charger, but also the 240 volt on the charger is killed by an interlock relay that the BMS controls. So we're double safe. Actually, we're triple safe because the CAN interface to the charger as well, or the power outlet, effectively what it is on the wall, also kills power too. So we're very safe, which is the whole idea of EV or properly built EVs, is that you've got multiple layers of fail safes. In this case, we've got the wall outlet is CAN bus. We've got the relay box, which is a normally open relay, so it's spring open with a magnet, which is a tricky one to find. So it actually, if you weld the contact shut, it will always try to open those contacts no matter what. And if that fails, the CAN bus interface between the charger and the BMS is also telling the charger to stop. And the BMS is also, you see here everything just drop out, is also telling the wall charger via CAN bus to stop too. So we've got multiple layers of protection to stop us from overcharging our battery pack, which is basically that is what we need to be safe. And when you overcharge lithium-ion batteries, that's when you get thermal runaway and EVs catch on fire. So that's a pretty huge thing, really, for me to have done. Massive thanks to some of the tech support I got from the BMS crew. These guys are freaking awesome. They really know their shit when it comes to lithium-ion battery management. I know it's big, it's a lot bigger and bulkier than a lot of other BMSs. This isn't just passive, this is active balancing. And also great tech support, and their literature is just uber detailed. There's so much depth in their literature. I've learnt a ton reading through that. So next big steps for this build is going to be getting this guy fully interfaced with the rest of the harness, the air gap board harness, and the motor. Then I've got a butt ton of configuration to do in there to make sure it's set up right. I'm pretty sure it's partially set up for the motor I've got, because I got the guys that sold me this to characterize my motor as well. So that means that there's a map for that particular electrical motor. Like, it's like a ECU map for a combustion car, but it's actually an electronic map, so it describes how the motor behaves electrically. So you need one of those to put into your controller, and that gets you that silky smooth operation, because the controller can anticipate where the motor needs to be for torque, and will know how it behaves at certain RPM and also certain power or torque requirements. So that's the next big move. So guys, get on board. This is about to get super interesting in the next little while. I can then put this in a box, get it safe, and then I can slam that box into this hunk of old junk over here. But ton of work to do there, but something that I can do. I know how to fabricate stuff. This was the giant scary bit. This is the not so scary bit. So yeah, looking forward to it. Big leap forward, so it's a big pump in motivation. I got pretty demotivated there. I was just hitting fault after fault after fault. But you know, you don't learn unless you got a little pain. So, and then hopefully I can get this rat's nest of wiring tidied up out of the way, because it's pretty scary as it currently sits. Lots of Wago connections. Love these little guys, but yeah, we got to get that sorted out. Lucky I had good color coding. Yeah, and then get it in there and get it going. Got to get a water cooling pump, got to get some other bits and pieces, but we're nearly there. So this is when we start to see things pull together. Anyway, dudes and lasses, thanks for joining me, and we'll talk soon. Cheers, bye.